All right. Good evening, everybody, and welcome to the first of our run up to the Eclipse events, Viewing the Sun Safely. My name's Sophie. I work in the public engagement team at the Rutherford Appleton Laboratory, so I get to do all of the really fun things like watching the eclipse with all of you and arranging all of these incredible talks. So in just a moment, I will hand over to the wonderful Simon from RAL Space, who is going to tell us a little bit about what we're going to see, what's going to happen, and also how we can see it safely, because that's always the most important thing that we think about here at the lab, but also everything on any science experiment, we should think about how do we do this safely to get all of the cool information, but not get hurt in the process. So like I said, this is the first of our pre-eclipse events. We've got another one on Thursday, a little bit later. That's about space weather and solar physics, so how we study the sun. And then next Monday, so that's the 10th of August, in the evening, we've got another short talk about Solar Orbiter, which is a really, really exciting mission that we're involved with here at the Rutherford Appleton Laboratory. That's looking at the sun, that's studying the sun, trying to find out more about our closest star, flying closer to the sun than any mission before it. So we're very excited about it. And then on the 12th, on the eclipse itself, we will be broadcasting our introduction to eclipses, and we're also going live to the Royal Research Ship, the Sir David Attenborough, which is just off the coast of Greenland at the moment. So much closer to totality than we are. So that's going to be really, really exciting. I'm very much looking forward to that. We will send out to you a recording of this little event because Simon's going to be showing us how to do a pinhole camera, how to make one. And so we want you to have all of the information so that you can kind of pause him and stop, so that you can make along with him as you go. So you've got your own pinhole cameras ready for next week. We'll also send out some more information about how you can view the eclipse, maybe where you can buy solar glasses, where you can find out exactly when the eclipse will be happening for wherever you are in the world. So don't worry about noting anything down, because we will send you all of that out tomorrow morning. All right. Well, I think that was everything from me. So thank you again so much for joining us. I'm sure you will enjoy this short thing about viewing the sun safely. And please do remember to put any questions in the Q&A, because Simon will be very happy to answer them. All right. Over to you, Simon.
Fantastic. Good evening, everyone, and welcome to this short talk on viewing the sun safely. Today, we are going to talk about who we are at STFC, and we're also going to discuss what actually is an eclipse. We also want to talk about why looking at the sun is dangerous and what we can do to prevent that danger by using solar glasses, as well as how to make a pin projector at home. So my name is Simon Blackshaw. I work within the Rutherford Appleton Laboratory along with Sophie, and my focus is on millimeter technology and space science. So RAL is part of the Science and Technologies Facilities Council, which is a public body which runs world-class science experiments for the UK and around the world. From our campuses at RAL and across the UK, we explore different areas of particle physics, quantum computing, space science, astronomy, like nowhere else in the world. So what exactly is an eclipse? The best way of describing it is as the moon orbits the Earth, the light from the sun is shining onto the moon. And very occasionally, as the moon passes in front of the Earth, it will cast a shadow down onto the surface of the Earth. Now, this shadow, as it crosses the land, the people on the land will look up and see that their view of the sun is blocked. And it's this act of the blocking of the sun by the moon that we call a solar eclipse. This year, on Wednesday, the 12th of August, there will be a total eclipse visible across Europe, and that includes Greenland, Iceland, and Spain. Being fairly nearby, the UK will see over 90% of the solar disk covered for a short while. And this is what we call a partial eclipse, because in this case, we're only seeing parts of the solar disk being covered by the moon. The whole eclipse, from start to finish, will last for about 2 hours. So this 2 hours is broken down from start to finish. In this case, so we're based near Didcot, so if we can use these timings for Didcot, our partial eclipse is going to begin just after 6:30 on Wednesday evening. The maximum point of the eclipse just before 7:15, and then the partial eclipse finally ending at last contact just after 8 o'clock in the evening. It's important to note that the sun will be setting by the time that the eclipse ends, so it's important that you get a good view to the west, clear of any buildings, of any trees, before you wait out to see the eclipse. If you are joining us from other parts of the UK, there's various websites which we will link to later to look up your own local times, because these will change by a few minutes. Now, time for the important stuff. Our eyes are not made to look at the sun directly. When we look at bright objects, the muscles in our eyes contract and distort to control how much light is being let into the back of our eyes. The sun is so bright that our eyes cannot respond fast enough and contract enough to block out enough of the sun's light before damage can occur at the back of our eyes. And this is true even on a cloudy day. So it's important for an eclipse and for any other times to never attempt to look at the sun directly without proper protection. Additionally, with a lot of the equipment that we have day to day, a lot of these cannot help us when we are trying to observe the sun. Particularly sunglasses, which we use to reduce the amount of reflected sunlight off people, off buildings, they are not strong enough to block enough of the sun's light to allow us to view the sun directly. Telescopes, binoculars, and cameras without proper protection can also be damaged. Their lenses, their filters, but also, if used incorrectly, can cause damage to our eyes as well. What can we do about this? The first example of what we can do is to use eclipse glasses. Eclipse glasses use film filters to reduce almost all of the incoming lights from the sun. And that means it's safe to look at the sun for a long period of time. I've actually got a pair here as well. It's important that before you use your solar glasses, that you inspect them thoroughly before use. You need to check for small holes which can form in the film or around the cardboard, as well as checking for any tears or any sign of the glue of the filters coming apart. It's really important to do this if you've got eclipse glasses from previous events. It's important to take extra care when you're buying eclipse glasses, especially if you're buying online. It's best to buy from a reputable vendor, avoiding sites like Temu. And Sophie has said that she's happy to share a list of reputable suppliers if you need to buy some before next week. When you are looking online, please have a look for ISO standards, the CE mark, or UKCA certification in the item's description. So just to recap on that, we can view the solar eclipse with our special film eclipse glasses, and we cannot use regular sunglasses, polarizing, stylistic or not, to view the eclipse. And this is a note of the ISO number, but we'll share that again later on. So what else can we do? We can make a pinhole projector. A pinhole projector is used to project an image of an eclipse away from the sun. So in this case, we are going to build a pinhole projector out of a shoebox, and we can project the image on the far side of the box away from the sun, where we can then view it safely. These are easy to make at home, and they're easy to use in your back garden. This is a list of the materials we're going to need to make our pinhole projector. We've got a cardboard box, and some paper, some aluminium foil, and tape and scissors to stick it all together, as well as a sharp point and a pin to make a small indent in the foil. It's important, if you need help, to cut any of the materials, that you ask a grown-up for help if you need to. Now, there's going to be a little bit of tech magic now as we swap from my slides to pinhole cam. And we're going to make our way over to the table.
Sorry, everyone. My camera has decided just to be a little bit grumpy today. Honestly, we genuinely send things to the moon, and yet we have difficulties with switching cameras. Give me one moment, everybody. Sorry.
You can see pinhole cam.
All right. I think everyone can see that now.
Yes.
Brilliant. Sorry about that, everyone. Let's go over. Here's Simon.
Right. Fantastic. Right, let's get started. The first thing we're going to do is to make sure we've got a suitable box. So in this case, I'm using a shoebox, but a cereal box or anything larger than that will work just as well. We've got our tape ready. We've got a scalpel if we need it. The first thing we're going to do is we're going to add a little bit of white paper, which is the same size as one of our ends of our box. And what we're going to do is use a little bit of tape just to fasten this paper in place. And this is going to make sure that we have good contrast on the back of our solar viewer. Excellent. So next, we need to make 2 holes in the opposite side to where we've just stuck our paper. And these 2 holes, we're going to use one for the light coming in from the sun, and a second hole for our eyes to be able to view the image. So I'm going to go ahead and cut those now. Can be a little bit fiddly to cut through cardboard, so you might just have to bear with me a moment.
And remember, everyone, while Simon is doing his cutting, we will be sharing this recording, so don't worry if you miss anything. We've also got some links to some other great recordings from NASA that are a really good way of doing it as well. Okay. Nearly there.
As well. Brilliant. So now we've got our 2 holes. We're going to use our aluminium foil, and we're going to cover one of the holes that we've just made in the foil. If you are using a shoebox at this point, it's worth taping up the top of the shoebox to keep that sealed. Just put a little bit of tape over the top. And this will stop it from opening again in the future. We can put our aluminium foil and make sure we're covering the hole that we've used.
You're too quick for me.
Oh, sorry. Try and make sure you can cover the entire of the hole that you've made, just to make sure that you're not letting other light in as well, as that can reduce the quality of the image. But in this example, that'll do for the time being. And if you have got any excess, you can leave it on, but in this case, I'm going to cut it off to make it nice and clear that this is the hole that we're going to be using to view our image. Finally, the last step we need to do is to make a very small hole in our foil. Now, the best thing to do is use a drawing pin. I don't think we have one to hand at the moment. That's okay. I'm just going to use the very tip of the scalpel. But yes, a drawing pin is the best, just to make a very small incision right in the middle of the foil, letting in as little light as possible. And that will mean that you get a nice, clear image when you look inside the box. And there you have it. A nice, easy to do solar projector at home.
Thank you, Simon.
Thank you. Right, let's run back down to the table. Fantastic. Can we hear me back in the chat? Fantastic. So when we send these out, we've got some extra videos which we can share, which show exactly the same as what I've just done. So once you have your pinhole projector, if the sky is clear, that's the important thing for hopefully seeing the eclipse, we want to stand with our back to the sun facing away. We want to lift the pinhole projector up to your head, using the uncovered side of the projector to peek through with your eye. And then you need to tilt your head gently until the box is parallel with the sun on the other side. At the start of the eclipse, you'll see a round bright spots on your paper at the other side of the box. And then as the eclipse progresses, there will be a large chunk missing out of that spot as the moon progresses over the face of the sun. If you're working in large groups, or if you need to make a projector quickly, or doing some small amounts of arts and crafts, you can use a single sheet of paper and make a small pinhole, which you can then project onto the ground, onto a large piece of paper, a wall. Really, anything with small holes is likely to project a view of the eclipse, including colanders, leaves of trees, and you can start to see these features everywhere. But the important thing is, if you are using projectors, you need to make sure you're facing away from the sun, so there's no chance of you ending up glancing at the sun by accident. Fantastic. So just to summarize, our eyes are not made to look at the sun, so we need to use protection. To observe the sun directly, we can use properly sourced solar eclipse glasses that are free from any wear and tear. Otherwise, we can make a pinhole projector to see the sun's image whilst we're facing away from the direction of the sun. And we don't want to use cameras, telescopes, or binoculars without proper filters, and never try to use sunglasses to observe the sun. With that, I wish you the best of luck for viewing the eclipse next week. Fingers crossed we've got clear skies, and I'm more than happy to answer any questions that you've got.
Fantastic. Thank you so much, Simon. So please do pop any questions in the Q&A function. We already have one, but which I will answer in just a second. Which is, why is the sun so bright? That's from Isaac.
Brilliant. Thank you so much, Isaac. The sun is so bright because our sun is made from a combination of hydrogen and helium. And that hydrogen because of its huge weight, is actually fusing together. And when those atoms are fusing together, it gives out this brilliant light. And it's that light combining as those elements fuse that is being given out by the sun and is shining on Earth.
Very, very beautiful.
Yeah.
Okay, Simon, I have a question. Have you seen an eclipse before?
I have seen an eclipse before. In 2015, there was a partial eclipse, similar to the eclipse that we will be seeing next week. I think it was a few percentage points less, so this will be the largest eclipse that I've seen to date. I had a very generous science teacher who kindly permitted me to have a quick break in our biology exam to nip out with the solar glasses and have a look at the solar maximum before going inside and finishing the rest of my biology mock.
Well, I hope you did well in the biology exam, but that sounds like a very cool teacher. Thank you, Simon's team. Brilliant. What type of damage can be done to your eyes when seeing a solar eclipse without glasses?
Not very nice damage, unfortunately. At the back of your eye sits an array of what we call retinas, which are cells which connects the back of your eye directly to your brain. Now, if we allow direct sunlight to shine on those retinas, they can actually be burned. And a burnt retina is something that can take an awful long time to recover, or sometimes doesn't recover completely, which can lead to blindness. And we don't want to risk that at all this week.
Absolutely not. Thank you, Simon. Oh, great question. Now, what is a lunar eclipse?
Oh, that is a very good question. So a lunar eclipse, if we think about our solar eclipse definition, where the moon is blocking light from the sun shining on the Earth, a lunar eclipse is where the Earth is blocking light from the sun shining on the moon. And it's actually the Earth's shadow that is being cast onto the moon as the moon is on its far side of its orbit from the sun. With a lunar eclipse, you will see a full moon gradually degrade into a dark circle before then you see a very dark red glow, which is caused from the refraction of the sun's light through the Earth's upper atmosphere.
Can look very, very eerie and
very
beautiful.
Spooky. Yes, I did wake up a few times very early in the morning to catch a lunar eclipse, and yeah, very, very stunning. They can span several hours, so they are longer than solar eclipses due to the size of the Earth related to the size of the moon. But yeah, they're still very incredible.
Yeah. Fantastic. So the lunar cycle lasts 28 days. Why don't we get an eclipse every month?
That is a very good question. Thank you very much, Catherine, for that question. As the moon orbits the Earth, it's really nice to think that it's going around in a perfect circle. In reality, it isn't. And we actually have a slight variation in the angle that the moon, Earth, Sun triangle makes. So sometimes it's a little bit higher than the Earth, sometimes it is a little bit lower. And so it's only now and again that the three bodies are in line just enough to allow the shadow of the moon to fall on the surface of the Earth.
Wow. How do the sun and the moon meet together?
That is a tricky question. We are in a very strange circumstance in the universe where our moon and our dominant star, the sun, are almost the same ratio in terms of how far away they are and how big they are. So the moon's angle in the sky is about, sorry, let me get this right. So the sun is about 400 times further away from us than the moon is. But the sun also happens to be 400 times bigger. And that means they almost make a perfect overlap when they see a solar eclipse. It's also important to note that the moon is moving ever so slightly farther away from the Earth every year, which means in a few 100,000, maybe a million years, we won't get solar eclipses anymore. or at least not total ones.
Yeah. Poor things, because they're really cool to watch.
But what a time to be alive.
Absolutely. And finally, or possibly finally, how dark will it get during the eclipse?
Here in the UK, it's possible that the sky will dim slightly. It won't be the same effect as it would be waking up in the middle of the night, for example. If we were in the path of totality, and if you know anyone that was in the 1999 eclipse, that will go to a full night where you're able to see the brightest stars, see planets during the day, during the eclipse. But for this eclipse, we're not expecting a massive dimming, but there might be a small effect.
Yeah, and actually in the email that we send you, we'll send you a link to an activity that you can do where you can actually measure the light levels using a microbit, or simulate the light levels using a microbit, a small little computery thing. It's very cool. I made one yesterday.
That's really exciting.
Yeah. So we'll show you that when you get the email tomorrow. We do have a few more questions, so we'll carry on for a little bit longer.
Absolutely.
When will the next solar eclipse be if we miss this one?
That is a very good question. The next total solar eclipse in the UK is not going to be until, I think it's near the year 2090, which is an awful long time away from now, unfortunately. It might be 89, it might be 91. But yes, that's going to be the next total eclipse visible in the UK. There are going to be other eclipses. The next total solar eclipse in the world after this one is next year, in next August, which will be going through southern Spain, through Egypt, and down the Red Sea. I can't remember if the pyramids are in totality, which could be quite exciting. But yes, significant portion of Egypt, Northern Africa, and down the Red Sea for next year. And we will have a significant partial eclipse for that in the UK, and that is the 2nd of August 2027. So a year yesterday.
Oh gosh.
We can do it all over again.
Yay. Okay. How do we know what time the solar eclipse will occur?
So we know when solar eclipses occur because we've been watching, as a species, the movements of the stars and the planets for a very, very long time. Something that was discussed in almost prehistoric times by Greeks, by Romans. And so as technologies got better, we are able to more accurately work out where the planets are going to be in relation to each other, particularly the moon. There is still sometimes things that change that. A big tsunami, something like that, can actually change how long the Earth day is, but only by fractions and fractions of seconds. So in terms of working out what time before or after dinner you need to nip out to see the eclipse, we can work that out pretty accurately.
We can. I think it's so cool that we do the same maths and we look at the same things that people did thousands of years ago. We've got records of people going and looking at eclipses and predicting when eclipses will be from thousands of years ago.
And some of the earliest computers from people like the Maya are designed for working out when eclipses are going to take place.
Absolutely. So cool. I could talk about it for hours, but I won't. Don't worry, everyone. Do other planetary bodies get solar and lunar eclipses?
They do, and that's very exciting. I cannot remember which Mars mission it was, but a Mars mission not too long ago took a photograph of one of the Martian moons eclipsing in front of the sun. Now, other planets don't get the same combinations of eclipses as we do on Earth. We are lucky on Earth to be able to have total and annular eclipses where the moon is slightly further away, so it doesn't cover the entire of the sun. But yes, other planets definitely do get eclipses from their own moons and bodies getting in the way of the sun.
It's very cool. We'll find out which mission it was.
Yes,
and send you a link.
There's a fantastic photo. Let's find it.
We'll find it and send it all to you so you can do it. It's really cool. I can't remember which one it is either, though. Can there be a shooting star in the eclipse?
Now, it also happens that on the evening of the 12th of August, we also have a meteor shower peaking. It's the peak of the Perseids, which means the night after the eclipse is the best night to go out and look for shooting stars, for meteors. The chances of a shooting star being visible during a total eclipse is not zero, but I don't know if it's ever been done. But it is definitely possible. For the UK, probably not, as we're not going to get total darkness, but it's certainly possible.
It would be so cool.
What a picture.
Yeah, it'd be amazing. And do planets with more moons get more eclipses?
I suppose they do. So we have Jupiter and Saturn, who have over 70, 80 moons each. I've lost count of how many moons we've identified of Jupiter and Saturn now.
Keeps changing.
It does keep changing as we find more. So planets with more moons do get more eclipses, but the thing to note with that is as those planets are so much further away from the sun appears much smaller in the sky for Jupiter and for Saturn. And so their eclipse possibly aren't as impressive, but you certainly get a darkening of the sky as moons and things pass over. It's going to feel very alien to see what that looks like.
Would be really cool.
It'd be very exciting.
Brilliant. Well, I'm afraid that is all we have time for now. Thank you so much, Simon. That was really, really great. And I am even more excited about the eclipse than I was at the start of it. So thank you all so much for coming. We've loved having you here. We've loved your questions. There were some really fantastic questions. So thank you very much for all of those. And we do hope that you will be able to join us online for some of our next events and also for the eclipse itself. It's going to be great. Vicky has actually found in the background some of the pictures of those beautiful eclipses from Mars. So she's just put the link in the chat. So do have a click on those because some of the pictures are just incredible, and have a look at all of the different pictures. So thank you again for coming. We hope that you all make some incredible pinhole cameras and get to see the eclipse for yourselves. Everybody keep all of your fingers and toes crossed for clear skies, because let's face it, this is England, so it'll probably be cloudy, won't it? But that's okay. We will still have an amazing time, I am sure. If you do take any pictures of any pinhole cameras, make any of them, do send us photos. We would really love to see them. All right. Well, I think that is everything from us now. It's been wonderful having you with us. So thank you very much. And we will see you hopefully in the next few weeks, I've lost all of my words, everybody. I'm too excited. We will see you over the next week and a bit at our online events, and maybe even in person. All right. Thank you, everyone. Bye-bye. Thank you, Simon.
Thank you very much. Thank you, everyone. Be safe and enjoy it.
Bye, everyone.